Now that we have a better idea of what cluster managers are and their usefulness with respect to our Spark applications, let's review some of the built-in means for spinning up Spark Standalone. To start, you need to copy a compiled version of Spark to the same directory on all of the machines that make up your cluster. And to ease your deployment, I suggest setting the Spark home environment variable on each machine so that they point to that location. Then, on your master machine, you need to have a conf directory in your Spark home directory. And inside there should be a slaves file, simply listing the address of each slave computer, separated by new lines. If this file is not present, then the local host will be used, which is nice when you're looking to run some simple tests. With that setup out of the way, you can then run the startall.sh file in the sbin directory, which requires a passwordless SSH to be set up from the master to each of the slave machines, as that's the mechanism it uses to set them up. That should be all you need until you want to spin down the manager, which you can do with the stop all script. Now, the standalone scripts are great, especially if you house your own hardware and want a simple spin up. However, the scripts won't work in Windows as of this recording. So, in that case, you'll need to manually launch each machine via the spark-class file in the Spark's bin directory. On the machine acting as the master, you simply pass in the master namespace. Then, you can spin up each of the workers using the same script, except running it directly on the worker machine, passing the worker namespace, and the newly created master URL. As far as stopping, you should still be able to use the stop all script in the sbin. But if that fails, all that script is doing is killing the Spark process, something you can again do manually. Now, you may also recall from the previous section that the standalone server defaults to allocating all CPUs and all but 1 gig of memory for each submitted application. So, if you don't want to rely on each application explicitly setting its number of cores, you can change the default from all cores to a set number by adding this export statement to a spark-env file in the master's conf directory, replacing bracket value with your specified value. And if you're looking for something more specific, you can always head over to the official documentation, which, yet again, isn't too bad on the topic. Next, as Amazon Web Services are fairly popular, having a means of launching Spark in EC2 or some other Amazon service is helpful. So, Spark originally came packaged with an EC2 script. It ended up being migrated to an AmpLab GitHub repository up until it was archived in 2017. I only bring this up because the new suggested tool, FlintRock, does not currently work in Windows. So that EC2 script may be your best option. Or the maintainers of FlintRock have posited that adding Windows support could be fairly trivial. But if you are using a POSIX system, then FlintRock is the currently suggested option for setting up a Spark cluster on EC2. Of course, the usual prerequisite for using any AWS service such as these is to set your environment with your AWS credentials, AWS Access Key ID, and AWS Secret Access Key. In fact, we'll need them in the next section, where we'll use Amazon's native CLI tooling, which works across all OSs, to set up Spark on Elastic MapReduce, or EMR. As that's the most straightforward way to see this all in action, let's head there and see it work.